To create a neural liquid our bodies can absorb, we should understand nanotechnology. For this is how small the molecules must be to pass through each cell's membrane.
Nature abhors a couple of things. One is instability and the other is asymmetry. It loves symmetry. In physics, we're always looking for symmetry. But for some reason, we assume, oh, water's perfectly fine in an asymmetrical state. No, it's not. It's going to form three-dimensional structures we call polyhedra. The next one is a cube. So we put four like this. Let's imagine we had four more stacked on top of these. But they wouldn't be stacked here, here, and here. They would fall in between the gaps, here, 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 and here. It's like you took half of this cube and twisted it 90 degrees. Then the next bigger polyhedron is a little more complicated. It's called a dodecahedron. But here's the interesting thing. I found in my work that the water molecules, for the most part, were coming together and forming huge structures, about 1,000 times bigger than can ever pass through this little active protein channel on the membrane wall of a cell called an aquaporin. See, a guy was awarded a Nobel Prize for discovering the aquaporin. It's an active protein channel. This looks like a little funnel. And only one water particle at a time can drop through the funnel into the cell. Only one is permitted. It's called an aquaporin. And the biggest particle that can get through an aquaporin is about a nanometer, a billionth of a meter. 1/1,000,000th of a meter stick. Divide a meter stick into a billion parts, and that's the largest particle that can get through the membrane wall of a cell. And most of the water particles, 95 to 98% of all the water you're trying to drink is made up of micron-sized particles. They're just huge. That's what happens when we take the energy from water. It's a form of thermodynamics that has nothing to do with kinetics. Nothing whatsoever to do with motion. It has to do with something else. And it's going to get us back to this. I never leave things entirely dangling. I'm going to go back to this. How could you engineer water? Very simple. Normally, the angle from this proton to this nucleus to this proton is about 104.5 degrees. Okay? 104.5 degrees. Now, it's this angle, actually, let's say that the ideal ground state of a water molecule, unattached to anything else, would be 104.5 degrees. But when they're locked into even the smallest structure, the bonding angle goes quite large, up to 122 degrees. But in the big micron-sized particle, it's somewhere about 109 degrees. Okay? So I had to figure out, how do I change the bonding angle? To get the water, as soon as you change the bonding angle, the size and configuration of the particle has to immediately shift. And you do that by charging the protons of the hydrogen atoms. You're going to change the protons, and we're going to put them into what we call a higher spin state. We're not going to change the spin integer, because spin is a quantum mechanical effect. And in reality, what it means is that every particle of mass in the universe is like a little engine engaged with vacuum space. I'm going to change the index of engagement with that particle in vacuum space. And I'm going to pull energy into the proton, and as soon as I do, what's keeping them at this angle is a little electrostatic field around them, the positive charge. And they're pushing on one another. They'll only get so close, and yet, according to the laws of quantum mechanics, they don't want to get too far. Unless I change the strength of the electrostatic field, they'll push away from one another and they'll form a bigger angle. And I've got them out to 122 degrees from one another. Oxygen, proton, proton. 122 degrees. When that happens, we get the smallest possible water particle. And it's actually sub-nanometer in size. We get particles that are not only 1,000 times smaller than the micron, down to a nanometer. They go on down to less than half a nanometer, down into what we call the angstrom range. They call me on a Saturday morning, and the professor of microbiology says, what should we do to test your water? I said, well, we can't photograph water under what we call an atomic force microscope. Because in a vacuum state, water won't stand still for a photograph. It's got to be done in a vacuum condition. And water is just going to move off. You can only photograph a molecule or an atom in a solid. But you can't do water yet. So we can't really photograph the water particle. And we can't compare my water to other waters. I said, how about permeation tests? Membrane permeation tests. Oh, he said, that's a good one. What we'll do is use cells. Isn't that the ultimate test, the cell itself? So they used plant cells. And the plant cells are prepared by dehydrating them with salt. And it's called a standard absorption test. And everybody in biology does a standard absorption test. And the physicist looks at the professor of microbiology and says, what are we looking for? And he says, nothing. Nothing ever happens in a standard absorption test. He says, you'll wait forever. You'll grow old and die looking for those cells to hydrate. It'll take hours for them to start, and sometimes days to finish hydrating. Okay, so they had 3 samples of highly purified water. One was reverse osmosis, one was distilled. I don't remember how the 3rd one was prepared. The 4th sample was my water. So they went ahead and took the dehydrated cells. They're under the microscope. Everybody can see them on a monitor. They add the water and they start timers. And they're waiting and waiting and waiting. And finally the physicist says, you know, we're wasting our time. Let's use Dan's water and see what happens. Okay. He puts my water on the slide, hits the timer and stands there, gets this amazed look on his face. He's staring at it. He lunges forward and hits the timer. He says, my God, the water started going in within 10 seconds and finished hydrating in 30 seconds. He said, this is amazing, astonishing. Nobody's ever seen this happen in history. It went through that cell membrane wall like it wasn't there. Oh, you have to do that again. That may have been an anomaly. Well, it happened over and over again. It went through the cell membrane like it wasn't there. So a biochemist in the Midwest said, yeah, but those are plant cells. We need to do it with the kind of cells we're made out of. So he works with a butcher shop, and he went to a butcher shop and got absolutely fresh killed beef, pork, turkey, and chicken. They go home and he has to quick freeze it, and they make thin slices to put on the microscope slides. Then they have a process where it takes, I believe, about 3 to 5 days to dehydrate them with salt. He said, by the way, the first time I called you in the summer of 2004, I knew from reading an interview you did on the internet with some guy that you knew what you were talking about. But he says, I'm like everybody else, I need proof. So he says, here's what happened. I went out and collected 19 supposedly high-tech waters. 19. And mine was number 20. He said, we went ahead and added these waters, and there's a particular dye we put into so we can see where it's going. We put the waters on the slides. Each water went on the 4 tissue types. And we wait, and we wait. It took a minimum of 3 days to see any hydration going on with any of those 19 water samples. Now this guy says to me, I don't want you to get a big head about this, but he says, your water went in and hydrated in 10 minutes. He said, here's what's curious. I took 1/4 of an ounce of every one of those samples and put 1 drop of your water in and let it sit there for a while, redid the test. It cut their hydration time in half. Went to 1.5 days from 3 days. He said, your water changes all these waters. Said it's thermodynamics. That's, whatever. I wanted to bring something into existence that really benefited the human race. But you know what? You ought to try drinking it all by itself. It does something very interesting. It'll get rid of those headaches you're having. Because this thing up here, unlike the rest of the body, is about 90% water. It wants to replace that fluid every day. And as that fluid gets dirtier and dirtier, but the water is so crucial. Consciousness will not occur without water. Trust me. Water and consciousness go hand in hand.